Okay, so you know how we talked to Jeff Silverman,
My name is Dr. Jeffrey Silverman.
the astronomer, a couple of episodes ago?
Yeah?
Well, there was something I wasn't telling you.
You've been keeping something from me?
I'm telling you now. After we talked about supernova,
Supernovae.
we talked about dark energy.
Shocker.
Because supernovae, which Jeff studies, was the key to discovering the existence of dark energy, which is the force that's pulling the universe apart.
Oh my gosh.
And no one understands what it is or why it exists. I'm Lindsay.
And I'm Marshall. Welcome to Tumble, the show where we explore stories of science discovery.
This show, we're talking about how scientists discovered one of the universe's biggest mysteries.
Dark energy. Okay, so I want to know, how did astronomers discover dark energy if we don't know what it is, or where it came from, or whether it's the dark side?
The way you say dark side is very distracting, but I'll try to answer your question. It started when astronomers tried to use supernova to measure how the universe's expansion is slowing down, which ended up being completely the wrong question. Here's Jeff.
Basically, by the mid-1920s, astronomers knew that the universe was expanding. All galaxies were moving away from each other.
In the universe, gravity pulls things with mass, like stars, dust, and whole galaxies, towards each other.
Yeah?
So astronomers knew that the universe was expanding or getting bigger since it got started in a big outward burst of energy and mass.
So you have the universe expanding, galaxies moving away from each other. They're all pulling on each other through gravity. So everyone thought that the universe's expansion should slow down. All of this mutual pulling should kind of slow down whatever was making the universe expand.
But something big was about to challenge all of that.
So, flash forward about 70 years, and in the mid to late 1990s, astronomers were looking at certain kinds of supernova to measure their distance and how fast they were moving away from us.
Astronomers use supernova, exploding stars that let off big bursts of light, as sort of the signposts of the universe.
I grew up in Southern California. One of the things I would look for on the horizon was the big In-N-Out neon sign. And I knew exactly what that looked like, and I could tell by how bright it appeared to me how far it was before I could get my double-double animal style.
So just like Jeff's fast food sign, supernovae look dim when they're far away and really bright when they're close by.
And as it gets further away, it gets dimmer.
Exactly. So imagine the astronomers' surprise when they figured out that the supernovae were getting dimmer, way faster than they expected.
Two completely independent groups using two different independent sets of supernovae found that the universe's expansion is accelerating. So the galaxies are moving away from each other faster and faster every day.
Wait, what happened?
This is a really big deal because there were two competing groups of astronomers racing to see who could discover the rate at which the universe's expansion is slowing down, like Jeff was saying.
It's like a race for nerds.
Yeah, I mean, astronomers are actually really competitive. But both of these teams discovered that the expansion is speeding up. It's accelerating. So remember how Jeff was describing the universe expanding like his trip to In-N-Out?
Yeah?
When we saw the In-N-Out sign, it was actually a little bit further away than you would expect from other measurements.
This is what would happen if dark energy got between Jeff and his double-double animal style.
Your GPS says it's 10 miles away, but I can look at that sign and I know it's really more like 12 miles away.
As long as we're still imagining the neon sign as a supernova, it's actually accelerating away from Jeff, which is as strange as it sounds.
Something is throughout the entire universe that's pushing against gravity.
It's a mysterious force.
Mysterious force.
Like gravity has an arch nemesis that it's been battling against for the history of the universe.
It's stronger than gravity. It's a form of anti-gravity because gravity should slow down the expansion, pull everything together. But something is pushing everything apart faster and faster every day. And we've now termed this thing dark energy.
Dark energy.
We still don't know a ton about it, but we do know that it makes up about 2/3 of the entire stuff in the universe.
Imagine what a huge discovery this is. It's like astronomers think they have a pretty good understanding of what's going on in outer space.
It's like you got your planets, you got your stars.
Yeah, you
your
got like all of the
nebula.
things that you know about, and you feel like we did a pretty good job knowing about these things.
And there's the moon being made out of cheese.
And then they discover that they don't have a clue about what makes up most of the universe.
So, wait, why do they know that it's most of the universe?
They think that it's 2/3 of the universe because that's how much dark energy astronomers believe must be pushing against gravity in order for the universe to be expanding this way.
Okay, so there's basically twice as much dark energy pushing as there is energy from gravity pulling on all the stuff in the universe.
Yeah.
Right, just like there are twice as many Sith Lords as there are Jedi.
Is that true?
No, it's actually the opposite.
Okay.
Okay, but how do they know that it's really a thing? Couldn't there be like some other explanation, like maybe a bunch of little hamsters are pushing the universe out?
Well, this is a really good example of how science works. It's like when you think you have something that might change the way that we think about the entire universe, you go ahead and you check your work.
You do your calculations, you make your measurements, you come to a conclusion, but you got to check your work.
Right, so you could be wrong.
It's like being in math class, but this time no one has the answer because the problem hasn't ever been solved. It hasn't ever been asked, or nobody's even thought of the problem.
You see, that's silly. I think the scientists just should have looked in the back of the book.
You got to say, okay, could this conclusion be a problem in the telescope I used? Or did I make a mistake in my calculation? Did I forget to carry the 1? Did I lose a decimal point?
They did try everything they could think of to explain it. I'm not sure if they tried the hamster theory, but
Obviously, it's the most rational explanation.
The thing that explained the data and the calculations and the numbers was the expansion is accelerating.
other scientists confirmed the findings using techniques other than supernova. So dark energy, whatever it is definitely a thing.
Dark energy is real, it's out there, the universe is accelerating in its expansion.
But what is it?
We don't know. It's a force. That's pretty much all we can say.
So magnetic forces can be attractive or repulsive. They can push or pull. Gravity is always attractive. Gravity always pulls stuff together. Dark energy is the opposite. It always seems to push stuff apart.
It's not a thing we can see. We can just hope to understand more about how it acts. It is changing the universe as we speak.
If dark energy continues to work like we think it does, then eventually most of the galaxies in the sky will be accelerated and pushed away from us. So if you talk to an astronomer 10 billion years from now, they're not going to have many supernovae to find. There won't be too many galaxies that we could actually see from Earth anymore. And you want to talk about, not knowing what's in the universe. So about 2/3 is this dark energy. Almost most of the remainder is dark matter, which we also don't really know what it is. Totally different than dark energy, except for it's dark and we don't know what it is.
It's like thinking that the entire world is made up of land and just recently discovering that oceans exist.
And that it has whales in it. Whoa.
I know, there could be space whales that are invisible.
Eating invisible plankton. That's what they eat, right?
Yeah.
Ghost Zooplankton.
dark
phytoplankton,
plankton.
Dark plankton.
It's a real possibility.
Or maybe they're eating the dark hamsters.
Dark hamsters. That's our show. Thanks so much to Jeff Silverman.
National Science Foundation Astronomy and Astrophysics Postdoctoral Fellow at the University of Texas at Austin.
If you haven't already, go back to episode 6 to hear more from Jeff in the episode we call The Mystery of the Exploding Stars.
And if you love mysteries of the universe, you're in luck because we're working on a bunch of these topics right now.
Often people ask us, how do we choose the topics we're going to talk about? And I mean, the answer is, it's things we are into and people we want to talk to. But what we really want to cover are the things you want to know about. So get in touch, email through our website, write us on Facebook, send us a voice memo to tumblepodcast@gmail.com, and your voice might end up in the show. You can also send us carrier pigeons or ravens.
Those don't work. We will not
Not
receive
yet.
them. I wrote and produced this show, and with a lot of help from Sarah Lentz.
I wrote the theme, so subscribe to us on iTunes, and when you do, because you've already listened, leave us a review right then.
And tune in next time for more stories of science discovery.